Okay, so today is a lot like yesterday in a sense that we're just practicing a mixture of the laws of exponents. Again, there is a certain order of operations that we have to think about as we're solving each problem. We first start with the power rule, which means I distribute the outside exponent to the inside exponents and multiply those. If a variable or a number does not have an exponent, it has an exponent of 1. Then the product rule, which says I multiply the coefficients. Then the two exponents, I add their exponents. The quotient rule says that I'm going to simplify the coefficients and then subtract the exponents. I like to circle the higher power, so that tells me where my result is going to end up. Then comes, I have to take care of any negative exponents before I can add and subtract. So the negative exponent law says in order to make an exponent that's negative positive, I need to move it. So if it's in the numerator, then I move it to the denominator. If it's in the denominator, I move it to the numerator. That's only for negative exponents, not negative coefficients. Then I'm going to add or subtract, and I can only add or subtract if they're like terms, which means they have the same last name. Now the zero rule is a floater in a sense that it can really pop up anywhere. So anytime I have a power raised to 0 or a number or exponent raised to 0, it equals 1. So let's go practice some problems. Number 10, all I see is the power rule. The power rule is whenever I have a set of parentheses raised to a power. So I'm going to distribute this 2 to those inside the parentheses. The negative 4 actually has a power of 1. So 1 times 2 is 2. So this is actually negative 4 squared. And then 4 times 2 is 8. Now, I do have to clean this up because I cannot leave it negative 4 squared. Well, negative 4 squared is negative 4 times negative 4, which is 16, and then y to the 8th. Now, number 11, I see the power rule, and the product rule. It's hard to see that little dot. So we first have to take care of both power rules. So I'm going to start here on the left. I'm going to distribute this 4 to the powers inside the parentheses by multiplying. So A, 2 times 4 is 8. B, 1 times 4 is 4. C, 3 times 4 is 12. Now I'm going to take care of the power rule on the right side, but I am going to bring down this multiplication. So now I'm going to distribute the 3 to the powers inside the parentheses. So B, 2 times 3 is 6. C, 1 times 3 is 3. Now I have the product rule. The product rule says that I'm going to multiply my coefficients, but here the coefficients are 1 and 1, so 1 times 1 is 1. And then I'm going to add my exponents. Now I am going to do this alphabetically. So A, there's no other A that I need to add the exponent, so it's just A to the 8th. Then B, 4 plus 6 is 10. C, 12 plus 3 is 15. And there's my answer. Number 12 is the the power rule. So I'm going to distribute this negative 3 to everything inside the parentheses. Remember, anything that does not have an exponent has a power of 1. So 1 times negative 3 is 6 to the negative 3. C, 1 times negative 3 is negative 3. And D, negative 1 times negative 3 is 3. Now here, I need to take care of my negative rule. My negative rule is anytime I have something raised to a negative exponent, in order to make it positive, I move it. So I'm going to move both 6 and C, but D to the 3rd is going to stay in the numerator because it's already positive. And all I'm going to do is move 6 to the negative 3rd and C to the negative 3rd to the denominator in order to make them positive. But now I do have to clean this up, so I don't want to leave it 6 to the 3rd. So 6 to the 3rd, use my handy dandy calculator here. 6 to the 3rd is 216. So my final answer is D to the 3rd over 216 C cubed. Number 13, I see the power rule and I see the product rule. So power rule says I'm going to distribute this negative 3. So 1 and 1, so 4 to the negative 3rd, A to the negative 3rd times A to the negative 4th. Then I'm going to take care of my product rule. Technically, the product rule comes before the negative rule. So product rule says that I'm going to add my exponents. So A is negative 3 plus negative 4 is negative 7. Now, here is where I see my negative rule. My negative rule says in order to make my negative exponents positive, I need to move them to the denominator or the numerator based on where they started. So both of these are going to move to the denominator. That means I have to have something in the numerator, and all we're going to put is 1. And now it's 4 to the third, a to the 7th. Now, of course, I do need to clean this up because we do not want to leave it 4 to the third. 4 to the third is 64. So my final answer is 1 over 64a to the 7th. Okay, number 14, I see the power rule, product rule. So let's take care of the power rules first. I'm going to distribute these 2's. So it's 3 squared, x squared, y squared, because 1 times 2, 1 times 2, 1 times 2, times, and I'm going to go ahead and clean up this 3 squared. So it's just going to be 9. Then over here, I'm going to distribute the 3. So negative 4 to the third, x to the 9th, because 3 times 3, and y to the 6th, because 2 times 3. And of course, I want to clean up negative 4 to the third. Now be careful here. If I do negative 4 to the third like this, I get negative 64. But I need to tell the calculator that it's negative 4, not just the 4 that's being raised to the third power. And it so happens that it is positive 64, or negative 64, so we did get lucky there. Now I'm going to do the product rule. So product rule says I'm going to multiply 9 times negative 64, which is negative 576. X, I'm going to add my exponents. 2 plus 9 is 11. Y, 2 plus 6 is 8. And there's my answer. Number 15 is just the power rule. So I'm going to distribute this 3 to everything on the inside of the parentheses. So it's 4 to the third. A is negative 1 times 3 is negative 3. B is 5 times 3 is 15. C is negative 3 times 3 is negative 9. Okay, here I want to clean up 4 to the third. 4 to the third, we've already seen, is 64. Okay, then I see my negative rule because I can't leave it where I have negative exponents. So the ones that I need to move are a to the negative third and c to the negative 9. So 64 and b to the 15th are going to stay in the numerator. And I'm just going to move a and c to the denominator to make their exponent positive. And I went ahead and left it negative. So there you go. Number 16 is the quotient rule. Quotient rule says I'm going to simplify 9 over 3, which is just 3. And then for the exponents, I'm going to subtract. But I like to circle the higher power. So 10 minus a is 2. But d is going to be in the denominator because 10 is higher than 8. So it's d squared. That just avoids the negative rule. Not that it's wrong, it just skips a step. Number 17, quotient rule as well. 6 over 4 simplifies to 3 over 2. And then I look at the a's. I have 5 and 1. 5 is the higher power, so 5 minus 1 is 4. And a is going to be in the numerator because 5 was higher. Then b, I have 2 and 3. 3 is higher, so b is going to be in the denominator. And 3 minus 2 is 1, or just b. 18, quotient rule again. 32 over negative 8 is negative 4. And it goes on top because 32 divided by negative 8 is negative 4. Then x, the higher power is 3, so 3 minus 1 is 2. And it's going to be in the numerator because 3 was higher. Then y, 2 is the higher power. 2 minus 1 is 1, but y is going to be in the numerator because 2 was higher. And z, 5 and 2, 5 is higher, but 5 minus 2 is 3. So z is going to be in the numerator because 5 was higher. 19 has the power rule and the quotient rule. So we're first going to take care of the power rule. I'm going to distribute the 4 to the powers inside the parentheses. So this is 2 to the 4th, and y, 5 times 4 is 20, over 10y to the 15th. It stays the same because it does not have the power rule. I am going to clean this up. So 2 to the 4th is actually 16. Okay. Now I'm going to the quotient rule. 16 over 10 simplifies to 8 over 5. And then 20 is higher than 15, so 20 minus 15 is 5, and y is going to be in the numerator because 20 was higher. Number 20 is the power rule and the quotient rule. But this power rule is a big power rule because the 4 not only distributes to the numerator, but it distributes to the denominator as well. So it goes to every power inside. So this ends up being 3 to the 4th. X 5 times 4 is 20. Y 3 times 4 is 12. Now the denominator, x 3 times 4 is 12, and y 6 times 4 is 24. I do want to clean this up, so we don't want to leave it 3 to the 4th. It simplifies to 81. Now I have the quotient rule. So the quotient rule, 81 over 1 is just 81. X to the 20th, x to the 12th, 20 is the higher power, so 20 minus 12 is 8, but it's going to be in the numerator because 20 was higher. 24 and 12, 24 is higher. 24 minus 12 is 12, but y is going to be in the new denominator because 24 was higher. Last but not least, I have the power rule, the quotient rule, and then subtraction. So first, let's take care of the power rule. This is negative 6 squared. A is 5 times 2 is 10. B is 1 times 2 is 2. I'm going to go ahead and bring down 12a to the 7th b minus 8a cubed b. Now here, I don't want to leave it negative 6 squared, so this is what I mean by be careful here. If I do negative 6 squared, my calculator says negative 36, but all it's squaring is the 6, so I need to put negative 6 in parentheses before I square it. Because technically it's not 6 times 6 and then tack on the negative, it's negative 6 times negative 6, which is positive 36. So just be careful with those. Now I'm going to simplify my quotient rule. 36 over 12 is 3. A's 10 and 7. 10 is the higher power. 10 minus 7 is 3, but it's going to be in the numerator because 10 is higher. Then b squared and b, 2 minus 1 is 1, but b is going to be in the numerator as well. So there's actually nothing in the denominator. Minus 8a cubed b. Now, at first glance, it looks like, Miss, these aren't the same thing, but you have to remember that when a variable is by itself, it does have a power of 1, so these do have the same last name. So 3 minus 8 is negative 5, and then I keep the same last name.